Board on. I am now sharing my screen with you, my darlings. And bam. All right, so you all, this is a, okay. So you all know we are in applied math. All of you have already enrolled in the class. All right, so today we were going to critically examine data representations and determine if they represent the same set of data. So again, the standards are the two standards that the state of Pennsylvania says should be covered in this topic. And we are, again, are analyzing and interpreting the data that we see. That is basically what we're doing. We've had our community meeting, which we just did a catch up. So I want you all to get some paper, because before we do the warm up, excuse me, I have some diagrams that I want you to copy so that you can make a better comparison. All right, but you all are doing well because you did the checkpoint. All right, so, and then the lesson is, again, I'm going to look at comparisons a little more just to make sure everybody gets the concept. And then cool down 3 is the assignment. All right, so we did our community meeting. So I want you all to copy this, because this helps as we move along our comparisons. And I used a diagram versus words because I think pictures sometimes tell the better story. So we know in a histogram, if it is skewed left, this is the look. The data is all pushed to the right. The tail of the data is on the left. And we see Q2, the median of the data is in the middle. Then Q1, the median of the lower half of the data is here. And Q3, the median of the upper portion of the data is here. So, So in a box plot, if the data is skewed left, what you will see is you will have a long whisker on the left, or let's say the left whisker is longer than the right whisker. And Q2 is closer to Q3. So the median of the entire data set is closer to the median of the upper portion of the data if it is skewed left. So again, that's why when we were talking about box plots, I said to you, the placement of the median matters, and this is why it matters. Because if your placement of the median will determine the shape of the distribution. Okay, so it matters where you put your median markers, we'll call them. So make sure that you get both of them, make sure that you get both of them and put them together like they have them here. So you can see the median of the lower half is at the same space. The median of the data set, the median of the upper portion, the maximum value, and the minimum value. Okay, so we see how the two compare. So when you look at a box plot, if it is skewed left, you should say in your head, left's tail longer than right. Median of data closer is up top. Okay, because we can make it plain. All right. So now, if the distribution is symmetric, that means that, again, the median of the data set is right in the middle. And then you have Q1, again, the median of the lower end of the data, the median of the upper portion of the data. But what you will see in the box plot is the whiskers are the same length, and the boxes, the median literally divides the box in half. So you can see from the symmetric diagram of the box plot, if we drew a line right down the median of the data set and folded it over, both sides would look the same, because remember, that is the definition of symmetric. You can divide, you can split whatever it is in half, and left side will look like right side. So again, everything is even if the box plot represents a symmetric distribution. Again, the whiskers are the same length, and the median of the data set is equidistant from both the median of the lower half and the median of the upper half. And then lastly, if the data is skewed right, and again, you know that means in a histogram, tail is on the right side, all the data has been pushed left. And again, we see the median is here, the median of the data set. And, excuse me, the median of the lower half, then the median of the upper half. So in a box plot, it's opposite of what a left skew was. So in a right skew, the right whisker is longer than the left whisker. And the median of the data set is closer to the median of the lower end of the data. Okay? So Q2 is closer to Q1 if the data is skewed right. So again, I think this review, because it is visual, gives you a better idea of what they look like. And again, remember, put this in your notes so that you will have a point of reference. And again, under left skew, remember, left whisker longer than right whisker. Q2 is closer to Q3. Symmetric, everything's even. And right skew, the right whisker is longer than the left whisker, and Q2 is closer to Q1. So I'm gonna give you a minute or two to do that, because it is 10 after, so our time is kind of moving pretty quickly. All right, are we good? Are we okay with this piece of the note taking? Okay. So let's do a verbal here. Now, for those of you who plan to go on in your studies, especially anybody who is going to study like psychology or anything like that, you're going to have to take statistics. So while we are used to our box and whisker being horizontal, when you see it in statistics, it will be vertical. But remember, this is still the lower end, and this is still this is the minimum, and this is the maximum. So when we look at these graphs here, right, we see left skew, right skew, and we see one of them, B, has an outlier. And remember, an outlier is a number that is not connected to the main body of the graph, and it is either far less than the minimum value in the data set or far more than the maximum value of the I lost it back. The maximum value of the data set. So when we look at A, all right, so we would say A is, oh, let's do it. I'm sick. Why am I stupid? Oh my goodness. Oh, I'm sorry. What that was about. Okay, so we are going to again match the box plot to the histogram. I always suggest do what is easy first. So I would say, because B is the only graph with an outlier, do that one first. Now, depending on who graphed the distribution will determine how they mark their outliers. So here, the outlier was marked with an X. So of course, B, the only one with an outlier, goes right down to 2. So we know that's done. So now, again, if we look at D, and I want you to write this on your paper, just A, B, C, D, and then I want you to match, because remember, this is like your cool down. Same thing. So we have A, B, C, and D, and we already know that B matches 2. So what would D match? Because what kind of distribution does D represent? Is it skewed left, skewed right, or would it be considered symmetrical? Okay. So now, because B looks like we could split it down the middle, or D, excuse me, looks like we could split it down the middle, that would match. Again, look, this distribution, look, the whiskers are about the same. Oh, I done lost somebody else. The whiskers are about the same distance, and the box itself is split in half. Left side, top side looks like bottom side. So we would match D with 3. This data is skewed to the right, and we just discussed if it is if it is skewed right, then the Q2 is closer to Q1. So 4 should match A. And C should match 1, because again, C is skewed left. So we see that the left whisker is longer than the right, and the median of the data set is closer to Q3. Okay, so you see how that would have matched up? And if those aren't your matches, let me know. All right, so we are running out of time, my dears. So we can pause this. Cancel that. I don't understand why it's not doing what I'm asking it to do. Oh, here we go. All right, so I'm now having a technical difficulty. I said cancel that. Let me close this. Maybe that'll help. All right, so ladies and gents, we will continue this on Thursday. I thank you all for coming. And I don't even understand what it's asking me to do. And I will talk to you all later. Remember, we will be having lab this afternoon. So if you need to, please stop by. There we go. All right, so if you need to come to lab this afternoon,